So today we're going to learn about 8.6 natural logarithms. The essential question for today that we're going to try to answer is how do we evaluate and solve natural logarithmic equations and expressions? That guy in the picture is John Napier, and he is known as the father of logarithms. So natural logarithms, a little bit of background information here. So remember, Euler's constant, E, can be used as a base with exponents. We did this earlier when we looked at putting e to the fourth in the calculator. We found a decimal. Now, if that is the base that comes with exponents, it can also be a base in a logarithmic equation or expression. When e is the base of a logarithm, we call it a natural logarithm. Log base e of x is commonly written as ln x. Notice the e does not appear. Ln stands for Logarithmus Naturalis, the Latin term for natural logarithm, which is why it's ln instead of nl. So if you see ln x, you know that that's the same thing as log base e of x. There are some rules for natural logarithms that will be useful for you later on. Ln e is equal to 1, so if we get that to happen, we're happy because we can change it over to 1 pretty easily. And e to the power of ln x is x. We're going to look now at how to simplify some natural logarithms, and the rules that we're going to use here are the same rules that we use to simplify regular logarithms, the power rule, the quotient rule, and the product rule. So for example, write 3 times ln 6 minus ln 8 as a single natural logarithm. First things first, we're going to use the power property. So we're going to take the 3 from out in front and move it to become an exponent. Then we're going to use the quotient property to rewrite those two logs, natural logs, as a fraction. And finally, we can simplify what is inside those parentheses. 6 to the power of 3 divided by 8 actually turns out to be 27. And that's our answer. Your turn, you try it. Go ahead and write each expression as a single natural logarithm. Hopefully these are the answers you got when you tried A, B, and C. So in A, first things first, power property, 5 would move to the back, would become ln 2 to the 5th. Quotient property would be ln 2 to the 5th over 4. That would ultimately simplify down to ln 8. Same thing with B. This 3 would move up here to become an exponent of x, x to the 3rd. Quotient rule would bring it down here, leaving us with ln x to the 3rd over y. Last but not least, we would do that with both logs. That 1/4 would come back up here, and that 1/4 would come back up here. We'd add the 3 and the x together using the power property, the product property to become 3x. That 3x goes in parentheses, and the 1/4 goes outside to show that 1/4 belongs both to the x and to the 3. Now we're going to look at solving a natural log equation. So here we have an equal sign. And we have natural log of this whole big group of information, 3x plus 5 squared equals 4. First what we want to do is rewrite it in exponential form. So remember, natural log right here is the same thing as log base e. So we can take that base e and put it over there with the 4. There it is. That gets rid of this ln. E to the 4th, we can figure out. 3x plus 5 squared, we can figure out. Now that we got rid of that natural log, we're happy, we can move on. Next we want to do is calculate e to the 4th. It, of course, is going to go on forever because e is a number that does not have any end or any repeating. It is irrational. So we're just going to stop it after 2 decimal places. Take the square root of each side. Remember, you're going to get a positive and a negative value. If we take the square root of 54.60, we get approximately 7.39 or negative 7.39. And then we just solve for x by subtracting 5 from both sides, dividing both sides by 3. X is approximately 0.797 or negative 4.130. We can check our work by plugging those two values back in to the original equation. Where you see x, you would plug in 0.797 or negative 4.130, and you could use your calculator to figure out what that is, and it should come out to be 4. Go ahead, you try it. I'm going to wait about 5 seconds, and then I'm going to reveal the answers. You might want to pause this video right now so you can try it on your own. Hopefully for that first one you got that incredibly large number, and hopefully for that second one you got that also incredibly large number. Next up, we're going to be solving an exponential equation. So here it's exponential because you can see an exponent with a base of e, so we got to get x down from its high shelf up there in order to find out what it is. First thing we want to do is we want to try to isolate that e to the 2x. So we're going to move 2.5 over, subtract it from both sides, and then divide each side by 7. So now we've isolated e to the 2x. We're going to do something called taking the natural log of each side. And so we write ln in front of e to the 2x and ln in front of 2.5. And when you take the natural log of e to the something, the natural log of e part basically goes away, and you're left with the something, but that something is no longer an exponent. Now it just sits on the regular line. ln 2.5 you can do in your calculator. If you look, you'll see that ln button near the log button. That's how you can figure that out. We can divide each side by 2. And then last but not least, using the calculator, we can actually figure out that x is approximately 0.458. Here's a couple for you to try. Again, I'm going to wait about 5 seconds, so you might want to pause the video, and when you turn it back on, you'll be able to check to see if your answer is correct. How did you do? I hope pretty well. Next up, we have investing. And investing is kind of interesting because it's an actual real-life application. And the question is here, we have an investment of $100. Now it's worth $149.18. The interest rate is 8%, which is quite high, and is compounded continuously. How long has the money been invested? So we're going to do some forensic accounting right now. We're going to start with our formula. Continuously compounded means we're doing the I equals PE to the RT. Fill in the parts that you know. Next, again, we want to get that e to the power of 0.08t isolated. So divide each side by 100. And then, to get that e to go away, we're going to have to take the natural log of both sides. We can figure out the natural log of 1.4918, so that's perfectly fine over there. But by taking the natural log of e on the right, we've made sure that can go away, leaving us with that exponent now on the normal line, 0.08 times t. We can then divide each side by 0.08, and using a calculator, you figure out that t is approximately 5. Go ahead, we have another you try it. I will wait another 5 seconds, and then come back with the answer. Hopefully you got about 6.5% as your answer for this you try it. Last slide, get excited. We're going to find the inverse. Now, this column on the left and this column on the right, they're two separate problems. So don't read across, read down. This first question is, what's happening from line 1 to line 2? So what's happening here from line 1 to line 2? What's happening there from line 1 to line 2? Hopefully you notice that the positions of x and y are switching. Here y became x, x became y, y became x, x became y. This is what we do when we find the inverse. Every time, switch x and y. And then what happens after line 2? Well, if we look over here, their ultimate goal in life appears to be getting y by itself. And if we look over here, the ultimate goal over here is getting y by itself. And sure enough, we are solving for y or isolating y, because again, we're finding the inverse. Go ahead. This is going to be your last you try it. You want to find the inverse of each one of these equations. And again, I will wait for 5 more seconds, and then I will put the answers up. Hopefully you got answers that matched these. If you are still struggling with this concept, we're at the end of our slideshow. My suggestion is that you go to the very beginning and click on that link, and it will take you to another YouTube video that will explain it in a slightly different way. I hope you enjoyed the slides.